Hello everyone, welcome back. Today we will continue our machine learning journey with another video. This time we will focus on one of the easiest supervised learning models that is called k-nearest neighbors. Last time we have discovered the difference between classification and regression. Also, we saw examples of classification and regression tasks. You can check that video using the link above. Let us start. Let us recall what the classification algorithms were. In classification, the output variable has to be a discrete value. In this way, we can basically classify among the finite number of categories. As you remember, in classification, we try to find the decision boundary, which can divide the dataset into different classes. The classification algorithms can be divided into binary classifiers and multi-class classifiers. In binary classification, you have only two categories as an output, like 0 and 1 or true and false. In multi-class classification, you have more than two categories as an output, like red, green, and blue. After reminding the form of the classification algorithms, we can now introduce the algorithm k-nearest neighbors. It is a supervised learning algorithm. So, as you remember, we have dependent variable y's together with independent variable x's. It is super easy to implement. You only need to calculate the distance between your test data and the training data. And the aim is to find the best decision boundary with a given k value. The algorithm has an assumption over the data, which is similar things are near each other. This may give you some idea about the steps of the algorithm. Given a positive integer k and a test observation x0, the KNN classifier first identifies the neighbor's k points in the training data closest to x0, which is represented by n0. It then estimates the conditional probability for class j as a fraction of the points in n0 whose response values equal to j. So that is probability of y equal to j given x equal to x0 is equal to 1 over k times sum over i's in n0 of I y equal to j. Finally, KNN classifies the test observation x0 to the class with the largest probability from the formula. Let us have a look at the KNN algorithm in action. Assume that you are given a k value of 3. You also have a training set, and suppose that your dataset includes two classes. One class consists of blue stars, and the other class consists of red triangles. Additionally, you are given a test observation, which is shown by a green circle. Note that you do not know the class of green circle, and you want to estimate its class based on your training dataset, consisting of blue stars and red triangles. The algorithm first looks at the data points in the dataset. It calculates the distance between the test observation and the training data points. Note that you can use any distance measure you want. After calculating the distances, the algorithm selects the first k closest data points, which is the first 3 points in our case. Based on the data points selected, the algorithm predicts the class of the test observation. In our case, we have only blue star and two red triangles. Since the probability of having a red triangle is greater than blue star, our algorithm, or KNN, will estimate the green circle as a red triangle. This is how the KNN algorithm works in action. Now, you saw how the KNN algorithm works both in theory and practice. At this point, you may wonder that how should we choose the optimal number of neighbors? In other words, how should we choose the k? And what are its effects on the classifiers? The number of neighbors k in the algorithm is a hyperparameter that you need to choose at the time of model building. You can think of k as a controlling variable for the prediction model. In the literature, it has been shown that no optimal number of neighbors suits all kinds of datasets. Each dataset has its own characteristics. When k is low, like 1, The decision boundary is overly flexible and finds patterns in the data that don't correspond to the biased decision boundary. This corresponds to a classifier that has a low bias but very high variance. As k grows, the method becomes less flexible and produces a decision boundary that is close to linear. And this corresponds to a low variance but high bias classifier. Let's wrap up the advantages and the disadvantages of the algorithm. First, the advantages. As I said earlier, the algorithm has an assumption that similar points stand closer to each other. Thus, we only need to look at the most similar k observations on the training data, which means there is no need for training. Another thing is that even though we have seen a classification example, one can employ the algorithm also for regression problems. In that case, again, you need to pick the closest k observations on the training data, then you can take the mean value of the k observations that you picked. The disadvantages of the algorithm are the following. First thing is the computational power. As you know, the algorithm needs to select the closest k points. To find these points, you need to go through all points available in your training dataset. Thus, it can require great computation power depending on your k value. Another thing is that you need to scale your training data since you're looking at the similarity based on distance. If your dependent variables are not on the same scale, then it makes your algorithm not reliable. Last but not least, it may be hard to find the best k value. It requires so much computation power when your data is so large and you have to try many k values. Today, we covered the k-nearest neighbor algorithm, its theory, and the way of working in practice. Also, we discussed its advantages and disadvantages. We look forward to hearing any feedback or questions from you. Thank you for watching our videos. You can ask questions by leaving a comment below, and we will try to do our best to answer it. In our next video, we will cover another fundamental algorithm in supervised learning, which is logistic regression. See you in the next videos. Bye.